Hello! Today in this video we are going to talk about key features of graphs, and we're going to specifically focus on asymptotes and intercepts. That'll be the new knowledge, and we're going to build off of this by talking about domain and range, which you already are familiar with. Again, while you're writing down the objective for today, while you're writing down the objective, while I figure out what's going on, while you're writing down the objective, I want to talk about this word right here. It is asymptotes, and intercepts, which you're already familiar with, and we're going to be talking about these guys. So that's our objective: identifying key features of graphs such as asymptotes and intercepts. So, activating your prior knowledge, the first thing we're going to talk about is domain. And remember that domain is all of the first values inside an ordered pair. The range is the second values, and the ordered pairs is just indicative of a relationship, especially when we're talking about functions. So, plain and simple, right? Domain values are my x's, my range values, these are my y's, and I can identify them easily in a table. We can also identify them, remember, from a graph. So here I have a graph, and I'll just go ahead and highlight, since we're talking about domain, that is my x values, right? So this function, a part of this function here, starts off at -3, that's my first x value, and it goes all the way to 7. Here for this one, it starts at -9, and it goes all the way to 7. So if I was writing the domain, and we're going to do this in interval notation. Remember, interval notation is where we use brackets and parentheses to describe. Since we're including these values, it starts at -3, and it goes all the way to 7. Inclusive. Now, if I'm talking about range, that is my y values, right? So I look at my y-axis. My function starts here. The lowest value for my y-axis is -8, and it goes up to -2. So my function exists. These are the y values for my function here. So if I wanted to write these in interval notation, the lowest value is -8, comma -2, and we include these, right? So I use brackets. Please go ahead, pause the video, write the domain and the range in your prior knowledge for this function. Okay, on that example, you should have gotten -9 to 7, and you should have gotten for range -3 to 5. -3 to 5. Okay. Alright, so go ahead again, pause the video, and try these examples here on your own. Okay, hopefully you pause the video, you try these examples. My domain for this example is -2 to 2, and so -2 to 2, and we're including these values, correct? My range, I actually like using the highlighter better, my range is -7 all the way up to +7. So that would be -7 to 7, and we're including those values. For this guy here, my domain, again, I'm switched to highlighter, my domain starts at, I don't know, let's say, kind of looks in between, so let's say -7.5, -7.5, and notice it has an arrow going this way, so that means it's going to continue on, right, forever, and I'm going to go all the way out that way. So it starts at -7, and it goes out that way, and that would be infinity. So I use a bracket there. Talking about range, again, my lowest value for my range is 0, and I go up, and I have an arrow going up, so that goes all the way up to positive infinity. So this value will be 0 to positive infinity. Notice infinity, we always use parentheses, right? I can't include that value, and my starting point is included, so I use brackets on that one. On these ones, I want to do with you just because we haven't really kind of looked at these functions. However, if I'm talking about domain, so my x values, my leftmost value, notice I don't have any points on this. I have arrows going this way, I have an arrow going this way. So my leftmost point is all the way out to negative infinity, and the arrow going this way means I'm going all the way to positive infinity. So therefore my domain for this function is negative infinity to infinity, and I have parentheses on those. As far as range goes, my range, I'm including all my values from negative infinity, same idea, right? My lowest value, I have an arrow going down, so that heads to negative infinity, and an arrow going up, that heads to positive infinity. Therefore, my range is negative infinity to infinity. All the real values. Okay. Here, this function again has two arrows on the end, so if I'm talking about domain, it's also going to be the set of all real numbers. So negative infinity to in positive infinity, right? I have an arrow going this way, essentially, arrow going this way, and that's going to be my domain. So negative infinity to infinity, and then my range, my lowest value, I have arrows going down, so that is negative infinity, right? My lowest value is negative infinity, and it goes all the way up, and the highest point is right here, let's say touching at the origin. So that would be negative infinity. I want that to be in green. Negative infinity to 0, and I'm going to include 0, and I don't include negative infinity. So these are some new kind of looking graphs that I wanted to give you a look at. So our objective today is identifying key features, and that's going to include domain and range, but specifically asymptotes and intercepts. So asymptotes, I know it sounds funny, an asymptote, this is a line that the graph of an exponential function gets closer and closer to, but it never crosses or touches. And here in this example, you can see a picture of an asymptote. And we generally show them with dashed lines. So here I have this asymptote. And if you remember about exponential functions, it gets really, really flat on one side, and then it will shoot up. So for this example, my exponential function, it's approaching this dashed line. If I was to zoom in really, really close, you would see that this exponential function never touches this asymptote. Please make sure you get this down in your notes. And here in this example, the asymptote is f of x equals negative 4, because the y value, right, my y value here for this line is negative 4. So f of x equals negative 4. Okay, again, asymptote, that's a line that an exponential function gets really, really close to, but it never crosses or touches. So let's go ahead and identify some asymptotes here. If I'm looking at this example, and I'm going to keep it simple, I'm going to go simple kind of explanations. So I have my dashed line here. My function's starting to flatten out at this value here, and we're only going to work with horizontal asymptotes. So my function gets really, 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 really close to this value, but it never crosses 3, right? It never goes above 3. So therefore, my asymptote in this situation is f of x equals positive 3. For this example, my function gets really, 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 really close to negative 8. I wish they were a little bit lower. But it's never ever going to cross that negative 8 value, right? It's never going to go below it. So therefore, my asymptote for this function is f of x equals negative 8. We're going to continue working with domain and range, actually, but I wish these were taken off. We're not going to focus on those right now because we've already worked with those. I would like you to pause the video, and I want you to identify the asymptotes for these two functions. And again, don't worry about domain and range. These two are on the back side of your notes, so flip over your notes and get these guys down. Pause the video and check back in. Okay, so hopefully you pause the video now and tried these. And you'll notice I put in these dashed lines here. That is my asymptote, right? This function never goes above this line, it flattens out there, and my function never goes below this line, it flattens out there. So this line is at 10, so that is f of x equals 10. That's my asymptote. My asymptote for this function, it's at 0, so f of x equals 0. Did you get that? Great job. I knew you had it in you. Good job. Okay, and then last but not least, this is old and easy information, an intercept. An intercept is a point at which a line intersects the x-axis or the y-axis. And an x-intercept, right, is here on my x-axis, y-intercept at my y-axis. Very, very easy, old information. So here, all you're going to do, I just want you to draw a point at any time they intersect. Anytime the graph intersects an axis, draw the points. And we'll go ahead and list them. So this point here, remember in ordered pairs, it's always x first, y first. That's the common error that we make here. We flip these. So my x value here is -5, 0. That's my x-intercept, right? I have a value for x. My y-intercept is here. It intersects my y-axis. That is at 0, right? X. I don't go anywhere on my x-axis, and then I go down 4 to -4. Okay, remember we use parentheses here. We've been working with interval notation. These are ordered pairs, so we use parentheses for points. Okay, this example, I have a y-intercept here, an x-intercept here. My x-intercept, I go over 3 on my x-axis, always x first, and then I don't go up or down. And my y-intercept, I don't go anywhere on my x-axis, 0, and then my y value is -6. Okay, and kind of what your notes are reminding you of here is, remember your x-intercepts always have a 0 value for y, right? Notice 0, 0, and then y-intercepts always have a 0 for the x value. Okay, that's always holds true. Okay, please go ahead and pause the video and try these two on your own. Here we have an intercept here, and an intercept here. We have an intercept here, and an intercept here. So let's go ahead and list those. That is -9, 0. And here we have 0, -8. See, I almost made the mistake myself. For my x-intercept here, I go to the left, -6, 0. And my y-intercept is 0, +4, 0. +4. That's negative, I promise. Okay? Very, very easy. Alright, to close out this lesson, your closure is to go ahead and try this one. So please fill in the domain range, asymptote, and x-intercept and y-intercept for this guy. Alright, so tying all of this together, hopefully you tried this without me, hopefully you're able to do it. I have arrows going in both directions for this linear function, so that means my domain is the set of all real values. I go from -infinity to +infinity. My range, same case. I have an arrow going down and an arrow going up, so that means my range is the set of all real values. And that happens for linear functions, right? They're straight lines, either going up, or here we have a negative slope. So my range is also green, -infinity to +infinity. Asymptotes. Oh, I'm so sorry. I didn't include this here. Hopefully you've asked this question. I don't have an asymptote, right? This graph goes this way, it goes up, it goes down, it covers every single vertical space. So I don't have a line. So this is non-applicable. NA. I'm running out of time. I got like 30 seconds left, so I'm going to close this up. And my intercepts are here and here. My x-intercept, -5, 0. That means 0. And my y-intercept, 0, -3. All right. Don't forget, like my video, subscribe. We accomplished our objective. All is good in the hood. Schwarberg, out.